Greetings, this is M squared, and this is just a review of some compound inequalities. We're not solving compound inequalities in this one, we're just reviewing. So, a compound inequality is when two inequalities are joined by either the word and or. And when a compound inequality, when they're joined by the word and, it means that you're trying to find the intersection of all the solutions for each one. So you want to find what's in common. When it's an or, you're trying to find the union of those. So you take everything in one inequality and combine it with everything in the other inequality. Sometimes you'll see an and written like this with the word and, but most often you'll see it written like this, where they take the and out and write it as an inequality with the variable in the middle. And then when it's an or, you'll usually always see them like this with the actual word or in it. These two are actually the same. This says x is greater than -4, which is what it says down here. And this says x is less than 6, which is what it says there. So I'm just going to show you how we'd graph these two different ones. So we have a number line. Remember that a less than is an open circle and a greater than or equal to is a closed circle. So I have a -4 and a 6. On my 6, I have an open circle. On my -4, I have a closed circle. And remember, I'm trying to find the intersection of everything that's the same. So if I was just to graph this one, the greater than, I'd have an arrow going this way from there. If I was to graph just x is less than 6, I'd have an arrow going like this. And since I want to know what's the intersection or what's in common, that's everything between -4 and 6. So most often on ands you'll see a line segment, and on ors you'll see more like this, and I meant to write that up at the beginning so that you could actually see what the graphs will probably look like. This is a line segment. This is actually two lines going opposite directions. Usually that's what you'll have. Okay, so for this one we have a 5 and a 7. Open circle because it doesn't have that little line under it. The 5 isn't included. A closed circle here. And if I was just to graph x is less than 5, I'd have a arrow going that way. If I was just to graph x is greater than or equal to 7, I'd have my line going that way. But since I'm combining them in a compound inequality and I want the union or everything in all the sets, that means I would shade everything in this set going that way and everything in this set going to the right. So that's my solution. Now every once in a while you get two different things that happen. You can actually get a no solution or an all solution. So I wanted to show you what that means. So for example, if I was to graph x is less than 3, so here's my 3, here's my 5, I would graph this way because that's where it's less than 3. If I was to graph greater than 5, x is greater than 5, I'd graph this way. And remember, if it was an or, this would actually have a solution, but the and means the intersection or what they have in common. There isn't any number that is less than 3 and greater than 5. I mean, 10 is greater than 5, but it's not less than 3. So this is a no solution, and every once in a while you'll see that. And then over here on the all solution, if I was to graph this, it's -3. That would be a closed circle, and a 10 would be an open circle. So if I was just to graph this, I would have had a line like that. A ray, actually. I've been saying lines, but it's a half a line, it's a ray. If I was to graph the 10, it would go like that. So you'll see that everything in this one and everything in this one is included in an or. It's the union. It's everything in both sets. Well, I'm covering everything on my number line, so that means the whole number line would be shaded in. So I really wouldn't need these open and closed circles. I just say the whole thing is included. So I wanted you to have a little review of compound inequalities because sometimes they get tricky, and in the next few lessons we will actually solve and graph some inequalities. This is M squared signing out.